This video should be fairly quick, and there should be something fairly magical at the end of it. So if you're here, stay here. The first thing that I need to point out to you guys, and this is a simple thing, if I asked you what is the derivative of dy dx, I expect everybody can tell me this. The derivative with respect to x of dy dx should be the second derivative, d squared y dx squared. So in this video, I'm effectively going to show you how we can take second derivatives in implicitly defined relations. So effectively, how we can find d squared y dx squared. And this fact is really what it's going to come down to. Anytime you need to take the derivative of dy dx, it's going to be d squared y dx squared. It's going to be the second derivative with respect to x. I only have one example here, and like I said, there's some magic right at the end. We get a really, really pretty answer for this. So I want to find the second derivative for this relation. So if I'm going to do that, I have to start by finding the first derivative. Right? So I'll find the first derivative of this by just finding dy dx, by using implicit differentiation just like we did previously. We just take the derivative of both sides with respect to x, and we solve for dy dx. You guys all should be able to do that on your own right now, and this one should be pretty easy. I made it nice on purpose. So please find dy dx. To do that, you guys are going to get 2y times dy dx, because that expression had a y, minus 4x, and the derivative of 10 is 0. Right? So now, if I want to solve for dy dx, I'll add the 4x over and I'll divide by 2y. I'll get dy dx is 4x over 2y, or I mean even better than that, 2x over y. Right? So that's my first derivative. Right, here it is. Yay. If I want to find the second derivative, I need to take the derivative of this derivative. Right? So in order to take the derivative of this thing, I'm going to have to use the quotient rule. Right? So if you're feeling up to it, try doing that quotient rule on your own. If you're not, you can sort of follow through as I do it. So first, on the left side, what is the derivative of dy dx? Remember, we're not going to use this middle term here. We're just going to use the 2 on the end. The derivative of dy dx should be the second derivative, d squared y dx squared. That's what we want to solve for. On the right side, over here, I need to take the derivative of this quotient expression, right? So I'm going to do low d high. Well, the derivative of 2x is just 2. Minus high, which is 2x, d low. Now be careful here. The derivative of y is dy dx. And this is all over the denominator squared, right? So this is going to be y squared in the denominator. Okay, so that's just the chain rule. This is me doing low d high minus high d low, square the bottom, go, go, go. Next up. By the way, remember this fact. Remember that y squared minus 2xy equals, 2x squared equals 10. We're going to use that later, so I'm reminding myself. So now I need to simplify this thing, right? But I noticed something. This dy dx here, I know what dy dx is. Dy dx is 2x over y. I can substitute 2x over y into this thing right here. I'll get d squared y dx squared is 2y minus 2x times 2x over y all over y squared. Right? So next up, and this is where things kind of get a little bit funky, this business of having a fraction with a fraction is just never good news. And so the thing I've told you guys, whenever you have a compound fraction like this, take the offending denominator and multiply the entire numerator and the entire denominator by that thing. So when I do that, I get, well, this y gets distributed to both terms in the numerator. When it gets to the first one, we get 2y squared. This other one is minus, the y's will actually divide out, I'll be left with 4x squared all over y cubed. So now, remember I said this thing right here? Remember I said we needed to remember that y squared minus 2x squared equals 10? So this is the magic that I promised you. In the numerator, I'm going to factor out 2. If I factor out 2, I'm left with y squared minus 2x squared all over y cubed. And what's really neat is that at the beginning of the problem, we were told that y squared minus 2x squared is 10. Which means right here where you see y squared minus 2x squared, that is equal to 10. There is no reason that I shouldn't just replace that with 10. 2 times 10 over y cubed. Turns out your second derivative is really nice. This second derivative we've been looking for in this problem is 20 over y cubed. Awesome.